In this Python program, we're going to look at a simulation that determines how many times it takes rolling 2 dice to roll snake eyes, 2 ones. In the end, we're going to add in boxcars as well as snake eyes. Boxcars is rolling 2 sixes, and that will give us an example of De Morgan's theorem. URLs for the two programs we're looking at are seen at the top. The first one simulates the rolling of 2 dice until snake eyes occurs. The rolling of the dice is going to be in a while loop because we don't know how many times we're going to be in that loop. And then that simulation is going to be repeated over a number of samples to determine the average number of rolls. And that's going to be a for loop. We do know how many samples we want. Then the second program is going to add rolling boxcars to the rolling of snake eyes. And we're going to see how that addition brings up De Morgan's theorem. Here we are looking at the snake eye rolling simulation program at a glance. We're going to look at it in more detail as we go on. But you can see the overall structure here, that there is a while loop within a for loop. So we have nested loops, just the loops of different type. And we're using a while loop because we don't know how many times we need to roll the dice until we get snake eyes. Whereas the outer loop is a for loop because we do know how many samples we're going to roll over. In this example, it's 500. Now we'll look at the program in some more detail. In line 3, we are importing the random class because we are going to use the pseudo-random numbers it provides us to simulate the dice. In 5, we are declaring and initializing the number of samples to be 500. That's how many times we're going to be in the for loop. And then we are going to calculate an average. And so we need to add up a number of things and then divide. And so we're going to keep track of a sum. And so that is initialized to 0 in line 6. Next, we're going to jump down into our inner loop, the while loop. So a while loop consists of the keyword while followed by a condition. And under that condition, we will repeat all the statements found within the while loop. So our condition here is that die 1 plus die 2 is not equal to 2. Snake eyes is when both dice have a value of 1, and that's the only case with the sum that equals 2. So provided the sum is not equal to 2, we want to continue rolling. That's our condition for staying in the loop. In 16 and 17, we sort of roll the 2 dice in our simulation, get random numbers between 1 and 6 inclusive, so it can be a 1 and it can be a 6, and we increment our roll counter. In lines 11, 12, and 13, we're seeing some initialization before we start this loop. So we're setting the roll counter to 0. We're going to be in an outer loop eventually, so the roll counter we can equal 0 is actually a reset. Every time we finish the simulation, we need to reset our counter. And then 12 and 13 are some initializations of the die 1 and die 2, and I made them 0, but the only important thing here is that their sum is not 2, so that we will get into our while loop. Line 20 is outside of the while loop, and it's reporting the number of rolls it took to roll snake eyes. Now we're bringing in line 9, the outer loop, the for loop. Again, this is a for loop because we know how many samples we want. We know how many times we're going to be in the loop. So then starting with 11, that is the setup for our while loop, which we've discussed, and 15 through 19 is our while loop, which we've discussed, and 20 is the print out of the number of rolls, again, which we've also discussed. The next new line is 21, so that's inside the for loop, but outside the while loop, and we're taking our roll count, which we reported out in 20, and we are keeping it as a sum. We want to calculate an average, and so we add up all of these roll counts that we are getting. And then in line 23, now you can tell by the outdenting that we're outside of the for loop, and we are reporting the average, which is the sum divided by the sample. So here we're looking at some of the outputs. So you can see that it takes a widely distributed number of rolls to get snake eyes. It was as low as 5 and as many as 117 and just in this little sample here. But it does have an average that comes out to be, in this case, the average over the 500 samples gave 35.4 on average number of rolls before Snake Eyes was rolled. In our Snake Eyes program, we used a while loop, and a while loop wants a condition under which you continue. But our condition, in some sense, was the negative of the condition. We had a condition for stopping. When we rolled 2 ones, we would stop, and then we had to turn that into a condition to continue for our while loop. And so we said when the sum of the two die 1 and die 2, was not equal to 2. What happens if you have sort of 2 conditions under which you might stop? So what if you're going to roll until you got either Snake Eyes or boxcars? Boxcars being 2 6s or a 12 for the sum. And so then if that's your stopping logic, if it's Snake Eyes or boxcars, if the sum is 2 or 12, and if you want to then invert that and turn that into a negative condition, then you would want to apply De Morgan's theorem. That tells you that the inverse of 2 ORed conditions is the and of the inverse of the 2 conditions. So again, the inverse of A or B is the inverse of A ANDed with the inverse of B. So therefore, our condition that you see in 10 is while die 1 plus die 2 not equal to 2, and die 1 plus die 2 is not equal to 12. We're applying the De Morgan's theorem. So we had an OR condition for stopping, but we had to turn it into a condition to continue. And so we needed the inverse of that condition. And when we invert an OR, we end up with an AND. We can adopt another approach where we keep the stopping condition as a stopping condition. So we can have as our condition for our while loop, while true. So that seems just a Boolean value true. So it seems like at that stage that we're going to be in an infinite loop and we'll always stay in this loop because the condition will always be true. And then in 1920, we are simulating the dice, random numbers between 1 and 6 inclusive. 21, we are incrementing the counter. And then we have within the while loop now an if, and we're asking if die 1 plus die 2 is equal to 2 or die 1 plus die 2 is equal to 12, then we break. So inside that if that's inside the while, we have this break, and that gets us out of loops, takes us out of loops. So now this alternative is we're working now with the sort of stopping logic. We have a while that would be an infinite loop, except that within the loop we have this if, and when the condition comes true of that if, then inside that if we have a break, and that takes us outside the loop, breaks the loop.